climate change is going to be much worse, no? Because now the water can be much higher, as you said. But it's not that I fix climate change and I solve this problem. This one is the nature of the shoreline. I'm saying that we are building in the most energetic place on Earth, in the most dynamic place of Earth, in which I see change at a human time scale.
Sergio Fagherazzi is an associate professor in the Department of Earth and Environment at the Marine Program at Boston University. He received his PhD in hydrodynamics at the University of Padua in Italy. You'll soon hear that he's in fact Italian. His colleagues study this from every angle possible, looking at all the ecological services. He's here tonight to talk about sea level rise and the impacts of that and storm events on the health of our coastlines. So please welcome Professor Sergio Fagherazzi.
I tricked you. I changed completely my presentation. I made it up like yesterday. And I'm going to talk about flooding and also salt marshes. And I want to start with Boston, because we are in Boston, or near Boston, and we humans do like to live near the shoreline, as you can see. Mostly because we can trade, and it's a good place where to arrive with a boat and exchange merchandise. So this one is Boston, a very old city, one of the oldest in the US. I come from Italy, and I come from another city that is as old, actually much older than Boston. And again, the same way than Boston, is a city that has a very strong link with water. It was basically built in a lagoon in a very shallow area. So again, you see that civilizations are always connected to water, and particularly to the shoreline. We like the shoreline. We want to live at the shoreline. However, there are problems. And this one is what happens in Venice. I showed you 2012, this one was not the most dramatic flood in Venice at all. Was high, but not the highest. And it's very common, actually. It's so common that students like me are very happy when there is a flooding, when there is a storm surge, because you don't go to school. Here in Boston you have snow days, in Venice you have high tide days, and so you stay home. However, tourists are not prepared, so whoever is walking around without shoes is a tourist. Because Venetians, they use boots, and they know exactly when the high tide is coming, because there is a system that is warning them. And as you can see, you have to survive in a city in which you have flooding every 2-3 years. So flooding is becoming common, or is common in some parts, particularly coastal cities. But it's not only Venice. Here you can see the 2005 hurricane in New Orleans. Again, we have a flooding event that is dramatic for the city, with a lot of losses, also human lives. And again, 2012 Hurricane Sandy. And we start to see a pattern here in which we do live at the shoreline, but also we somehow are unable to manage what's happening there. And very often we see all this water coming in because of hurricanes, because of a surge, and also because of tsunamis. Okay? So yes, the shoreline is a very good place where to have a city, but there are also a lot of problems and a lot of threats. And particularly there is this flooding concept, this idea that eventually, sooner or later, I might have water in my backyard. And sometimes the water is very fast, because this one is a tsunami, and so this is very dangerous. These are my photos. I took them. I was there in 2006. And you can imagine, you could think that this is the same hotel before and after the tsunami, but in reality are two different hotels, in which this one was lucky to be only a few meters higher than this one. So I stayed here, and I had an amazing time, because the hotel was like 5 stars. My bathroom there is big like my living room in Boston. And then I walked down. I went there to look at the tsunami tsunami effect. I went down at the beach, I turned 200 yards, and this is what I saw. Okay? And the total destruction of another hotel that was much lower. And here, I'm sorry to say, but here a lot of people also died because when a tsunami is much faster the water, so it's difficult to swim. So this is a first message. We are talking about meters here. We are talking about a difference in elevation of meters, or even a fraction of that. And a difference in meters can be life and death. A difference of meters can be your house is going to be totaled completely. A difference of like even few centimeters means your life is completely disrupted. Okay? So what is my job? So I'm focusing on coastal landscape. This is an example, is the Lagoon of Venice. This one is the historical city of Venice that was built basically on a salt marsh. Salt marshes are areas that are green here, that are basically go underwater at high tide. So when the tide is high, salt marshes are underwater. And then I have all these possible elements of the landscape. So my goal for research is to see how these different elements interact and to see how marshes can change and become tidal flats, to see how the barrier islands can move, the tidal inlets they can become larger or smaller, the channels can change in time. So I look at the change of the topography at the shoreline, mostly in places without humans, because I want to have the natural system. So now I want to focus more on the salt marshes and tidal flats, because I have a story to tell you. By the way, I grew up on this island here. It's called Lido. It's a very thin island. There's only one road, mostly, but there are 20,000 people. I go to the beach. I used to go to the beach every day in summer. So this is another example of tidal flats and salt marshes. This is a typical intertidal environment. It's called intertidal because it means that it is regularly above water or underwater. So this one is a salt marsh. You have all this vegetation. It's a very unique vegetation because it has to survive salt water and flooding. And this one is a tidal flat. You see, it's lower and is muddy or sandy. And the water keeps going up and down. This one is my student working in Plum Island. This one is near Boston. It's a very interesting place because it's a Boston without Boston. If you want to see the real landscape of Boston, you should go in this area here. Low tide, the marshes are subaerial. High tide, the marshes are underwater. And now we understand that there are places on Earth which typically get flooded. So this is natural for them to go underwater, okay? And vegetation is very good at surviving going underwater. Now I'll show you a little bit on my different projects. So I work here, Plum Island Sound is north. This one is a Gloucester, is a Cape St. Anne, is up there. And I repeat, this is the place in which you can see how Boston would look like without the buildings, without the infrastructure, without human modification. And mostly what you see an intertidal landscape with the water, and it's going up and down, and you have marshes. Here we do like a big experiment. We fertilize the marsh just to see what's happening there. I do the same in Virginia. Again, very beautiful lagoons in the eastern shore of Virginia. These are all centers that are funded by NSF, in which we collect data for 20 years or more. And in particular, you see marsh deterioration. It's a terrible job. I go to the beach basically to work, and I look at this vegetation. Again, another environment. Here we are in Washington State, and this one is a mud flat. A lot of mud, you get stuck in the mud, and it's difficult to get out of it. We used a lot canoe to be able to go around without getting stuck with the boat. And as you can see, this one is high tide. Look at high tide. The entire area is flooded. In a low tide, I have all this area emerging. This island is that island. So high tide, I get 3 meters of water above this level. And again, this one is in Vietnam. So this one is a forest at the mouth of the Mekong Delta. And again, you see, I have different vegetation. Now I have a forest of mangroves, but is emergent and is go underwater. So I keep seeing in my research areas that go underwater once in a while, once every day, once every month, sometimes some places only once a year. Still they go underwater. And the entire system, the vegetation, the animals, are adapted to go underwater. So this one is a very important person, is a crab, no? And what is amazing that you see in these places, that before the tide is coming, so it's low tide, there is no water, just minutes before the tide is coming, there are hundreds and thousands of crabs coming out, and they move their claw in this way. They fight basically against each other because their goal is to position themselves in a better way to get food. So they're very territorial and they want to push away the other crabs. But you see thousands of them. So they all know exactly the moment in which the tide is coming. I didn't even know the tide was coming. I saw them and then I heard the noise of the tide coming in. The same, you can see the same in the Amazon River. There are all these crabs that they are synchronized in terms of life with this flooding. So the animals, they know exactly when the water is coming, when it's leaving. The entire ecosystem, the entire food chain knows about water flooding, including the trees. This is me. I have a major net because it was full of wasps. So in all our studies, not only me, but many other researchers, we are trying to understand how these salt marshes work. And what is very surprising, they are very good at adapting to sea level rise. And in particular, I have a lot of feedbacks that allow the marsh to go up in time. So the marsh can be so high. If sea level is rising, the marsh is rising in time. Why? Because they accumulate sediment on top of the vegetation. Vegetation is very good at trapping sediment. So there is mud and sand coming in, and I get layers of sediment, and the marsh is able to track in time if sea level is rising. So they're always able to survive sea level, almost always able to survive sea level rise. Okay? So again, is an ecosystem that is very good at surviving during flooding, and also they are able to mitigate sea level rise. And you can see here, no? Look at the marsh was here. You can see the roots back in the days, no? Was 20 centimeters lower when sea level was lower. Not only they inject carbon, no? All this material here allows the marsh to grow and always be in equilibrium with the sea level. Sea level is going up, the marsh is going up. Not only, I have all different vegetation species that they know exactly where they are with respect to sea level. So this is called zonation. I have different plants. These one are the plants that are very good at staying underwater. Those are the plants that they need to stay much higher to survive. But they know exactly where to stay to survive. And you can see here, no? So all this part here is a marsh, and the water can come here eventually. But then if I go up there, you see I have a forest. I change vegetation because it's higher, no? So all these plants know exactly where they are, and they know exactly what elevation need to be to survive. The same also the animals, not only the crabs I show you, but the entire food chain, they know. They take advantage of all these different elevation in order to feed, in order to nest. So they probably nest in a dry place. They come down here to feed. I have different fish here, and I have the crab. The entire place, the entire animals know exactly how to forage depending on the elevation, and they also know exactly when the tide is going up and down. Okay? Because they have to survive in a very hostile environment in which there is flooding. Why I tell you all of that? And more, even more. This is our research. We show that if I have a hurricane, the marsh is very resilient. So if there is a hurricane, if I see after Hurricane Sandy, the salt marshes in Barnegat Bay, New Jersey, there's no very small erosion. I see salt marshes down in Barataria Bay in Louisiana after Katrina, very little erosion. This vegetation surface is very resilient against erosion, particularly for many reasons. One is that it's going to go underwater, no? So it's going underwater and the waves are going to go on top of it. And also the vegetation, the roots stabilize the substrate. So if I see here the erosion, I get only 1% of the erosion of the marsh is during hurricanes. See, only 1%. The dark one is how much erosion I get during hurricane. It's nothing. So it's a system, all these ecosystems, because they've been there for like a million of years, no? They are very adapted to living at the shoreline. They know exactly what to do when there is flooding. They know what to do when there is a hurricane. They are resilient. The same is for sea level rise. Now, if I have sea level rise, my marsh can just move upland. So sea level is low, is here. If sea level is rising, my marsh is going to go up and it can survive. Okay? These are examples, one our site in which the marsh is transgressing and is occupying, is invading the forest. You see that the trees are dying because they get the salt water and the marsh is moving in. Very resilient ecosystems. Very animals and plants, they know what to do to survive to hurricanes, tsunamis, sea level rise. Why I tell you that? I tell you that for a reason, because when we develop the coastline, we tend to take these marshes and develop them in housing or infrastructure. No? For example, if I see San Francisco Bay, all the marshes in San Francisco Bay, they were completely reclaimed in time and transformed in, for example, the airport was a salt marsh down here. The entire area here and also up in Petaluma are mostly offices and houses. So what we see in this landscape, I see that I take a place that used to go underwater a lot of times and I change it in development, okay, for humans. What about Boston? The same is for Boston. So Boston used to be only a small peninsula, that was with 3 drumlins, but a lot of the area around Boston, including also Cambridge up here, used to be a marsh, which is the green one, or a tidal flat, which is the white one, or a channel or a river. Okay? Look at here. These one are the Dorchester tidal flats. Was underwater. We develop the intertidal area. So we don't even know that. We don't even know that. So, and then we are surprised that there is flooding. Okay? We, by definition, take places that go underwater on a regular basis and we change them in houses, buildings like this one. I bet that this place here, since in East Boston, no, it's probably up here, no? Or could be even closer to the salt marsh. Again, if you see the way Boston developed, we took advantage of topography. We always built first very shallow areas because it's cheaper, no? It's cheaper to fill a tidal flat like Dorchester. Look at Dorchester. It's going to build exactly following that topography there. It's easier to build something that is very shallow than very deep, no? I have to put less dirt to make it higher. So in time, we develop Boston in a place that look exactly what I do for work. Look exactly all those places I showed before in which I have water coming in and out. And in fact, if I see historically, this one are photos of the Charles River. This one is Storrow Drive, when it was a racing track, okay? And this one is Back Bay. Historically, the Charles River was tidal. So it means that the tide was going up and down in the Charles River, okay? And you can see here, a low tide, I have mud flats in the Charles River. was very dirty. Then what we did, we created a lock. We locked the river out here. This one is the Longfellow Bridge. There is a lock here that doesn't allow the tide to get into the Charles River anymore. Okay? So Longfellow is not only a bridge, but is also a poet who used to live in Cambridge, and he was in love with this woman in Beacon Hill. So it took 7 years to convince her to marry him. And for 7 years, he was going up and down, because he was professor at Harvard, from Cambridge on foot, doing the bridge and going to Beacon Hill to bring presents and flowers to the fiancé, or not fiancé, okay? So he knew exactly what was a tide. He knew exactly what was the water level here, because every time it was coming here, the water was going up and down, up and down. Sometimes it was like that, sometimes it was full of water, sometimes it was empty, back and forth. Sometimes it was a storm and the water was higher, sometimes it was very low, even too low, okay? Now we completely separate ourselves from this environment. We completely remove ourselves to the landscape of Boston. And in fact, if you see one of the most famous poems of Longfellow, the tide rises, the tide falls. Everybody in Boston knew about tides because it was a port city. They knew because the boats were coming. They knew because the water was coming in and out, even to access areas. Okay. Now let's look at here. So for some of you, you like football. I don't like football too much because I like soccer. But for you, you don't see a lot of difference, no? We won the Super Bowl in 2004, and we won the Super Bowl in 2014, no? 10 years difference, no? Someone looks a little bit older, but not too much older, and we are all happy. But then there is a detail that to me was very surprising. Look at here. High tide, 7:45 a.m., high tide, 8:12 p.m., okay? So the Boston Globe, historically, the Boston Globe was reporting the high tide. How many of you here know when is high tide today? No. Yeah.
Oh, I don't know today.
Not today.
I know in most days.
So, because you fish or?
I go across the Neponset River to get to work.
So you are like a Longfellow, and you are able to expose yourself to the landscape around you, and you know more what's happening here. But it's very, we start to lose. In fact, the Boston Globe dropped completely the tide. So then we can ask ourselves a very disturbing question to me. And one is, how much is the tide in Boston? How high is the tide?
8.6 to 12.2 feet.
But again, how many people know that? You are the exception that confirms the rule. And also, what was the highest storm surge ever recorded in Boston? And even more disturbing, how many of us really know what is the elevation of our house compared to high tide? And all in a sudden, no.
15 meters.
50. So you are in a hill. You are in Beacon Hill.
Dorchester.
Dorchester Heights.
Small hill.
So again, we can see that slowly we are losing contact to our environment. Yet we built on places in which the water was coming in and out regularly every day. And these people knew. Back in the days, they knew more than us. These people, proper New Englander, they used to go on the marsh to hay. So the entire New England, including also Boston, they were going to take this one, Spartina patens, and they were haying for cattle, no? Because it's the only place where you can find grass in the East Coast, because all the rest is forest. And they used to put all the hay in stacks like that, and then they were coming at high tide to pick up the hay. Okay? So they knew exactly, their life was very close to the tidal rhythm that we don't have anymore.
And that was for cattle?
For cattle, yeah. I don't know how the cheese came out, but I know that in France they use salty. So in France they use the same for the Mont Saint-Michel. They have a special cheese that comes by haying the marshes, and they get salty cheese. The They have cows in Louisiana on the marsh, but the cows are not very happy because they think they get stones, they get liver stones because of the salt. And again, even if you were a climber, you know exactly when it was low tide, because the only way for you to go and get your clams was during low tide. So we're talking about a society that had a very strong connection to the ocean, and they know exactly where they were, in terms of elevation, in terms of where the water goes, how high is the water, and when. Now, we start, for us now, only dramatic events can make us realize where we are in terms of topography. Only if there is a hurricane, and here is the sign of a Katrina. This one is a Starbucks that they reopened in New Orleans. It's the sign of the highest level of the water during Katrina. These ones are the sign in Venice of the different floods. So the highest, the Katrina of Venice was 1966 November. See, they also remember the day. Look how much water you get, 1-2 meters of water. So that could be very damaging for the city. Even in Japan, they knew exactly, historically, where the tsunamis were arriving, the highest place. And in fact, the people, they were building these stones, and on the stones carved is written, high houses are the peace and harmony for your family. Remember, never build below this point. And they completely ignored that. Okay? So we're talking about a society that was very, they knew exactly what location, what elevation they were, because they were subject to these extremes. We, because we have technology, we remove ourselves. We put a lock in Charles River and we don't care. And some places here are very low. Like I'm in Boston University. We are probably 1 meter above mean sea level. About high tide. Okay. So eventually there's going to be a storm or a flood, and we go underwater. Actually, my basement goes underwater. And it's good because I'm the only one who can put stuff in the basement, because I have all my stuff go underwater anyway, because I have like canoes and instruments. So all the basement is mine, basically. So remember, we need to know more about that. And then I want to give you a geological perspective. Look at sea level during the last 120,000 years. This one is sea level. Look how it's moving back and forth. It's moving like crazy. So what is a shoreline? We think a shoreline as something fixed. We build our infrastructure in something that is very dynamic. Does it really make sense to think about shoreline as a static environment? Does it really make sense to think that I build a house at the beach and it's going to stay there forever? It's crazy. We're crazy. Okay? If I think in geological time scale, look at here. This one is 3 million years ago. The shoreline in the East Coast was much higher. I cut off a big chunk of the Carolinas. Okay? We are talking about a boundary which is always moving, always, 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 always. Okay? So we need to think in a different way. If we want to live at the shoreline, we need to think a different way. Nothing is permanent. And also, it's the place in which you have the highest energy in the surface of the Earth, because the ocean is funneling all the energy at the shoreline. I get hurricanes, I get tsunamis, I get waves. Okay? So I'm talking about the most dynamic environment on Earth. And yet we want to build in a way that is very permanent, and we think I buy a house at the beach and it's going to stay there for my children and the children of my grandchildren, and then the beach is going to go, and I'm very surprised. I'm surprised that there is the water when I'm in New Jersey and I get 3 meters of water. I'm surprised I'm in New Orleans below mean sea level and I get 5 meters of water. Okay? Doesn't make any sense. So Venetians, because they had much less technology, they knew that. And this one is a very famous engraving in the 17th century, and there are two ladies with very different aesthetic standards compared to now, and one is half naked. And it's half naked because it's coming from the ocean. This one is the ocean, and this one is the land. And as you can see, the ocean has algae for her, and the land has a marsh vegetation on the head. And these two ladies are fighting. And they're fighting without any mercy. They're poking their eyes, they're pulling the air, okay? This one is what the Venetians thought about the struggle of the ocean and the earth for the control of Venice. And this one is Venice on the foreground, okay, background. Venice, this is us, this is the humanity. We are bystander in front of the fight between the ocean and the land for the control of the shoreline. So remember, this location is ephemeral. We live in an ephemeral location. Boston is ephemeral because it's exactly here in between the fight of these two titans, okay? And we're going to be caught in the fight. Does this apply also nowadays? Yes, it does. You see? The same. I have the thing, which is the earth of the land, and I have a silver surfer, and the silver surfer is kicking the butt of the thing. The peerless power of the silver surfer. The ocean is winning nowadays. And we see that. You see? Silver surfer is winning in Venice, in New Orleans, and maybe also in Boston, and also in New York. And by the way, I caught the silver surfer in Venice. So every time there is a flooding of Venice, there are always Americans. I know there is American, by definition. There are always Americans trying to do the most crazy thing into the square. Usually they swim. This case was able to go and surf in Venice. So remember the goal. So this is an open question. How do we adapt? We need to rethink completely how we survive at the shoreline. I think we have to change completely our way to approach the shoreline. Nothing can be permanent because it's always moving. We need to be like this little crab, okay? And we need to be ready to receive the flooding, you know? And we call the flooding with our claw, okay? And then, for example, you see this guy here. Actually, my brother does the same. He's not my brother, but my brother has a store in Venice, and they have gates. They put these gates because they are able to basically prevent minor flooding with the gate. They put a pump out, okay? So there is a siren in Venice that goes off at night, during the day, depending. There's a warning for a high tide. So my brother has to go, even if this is a night, has to go there, take the boat, go to Venice, go to the store and put the gate. If he forgets to put the gate, the water comes in. And sometimes he lost merchandise, he lost a laptop. The water is not clean because there's no sewage in Venice. So whatever you do in your bathroom goes in the water here. So you can have also damage. But again, we can see how out of necessity we are adapting to this situation. So this is the question. How do we rethink ourselves in terms of living at the shoreline with all this information that this place is crazy?
I'm going to pass around this microphone if anyone has any questions.
Where do I find out how high my house is above high tide?
I think there are very good FEMA maps, and they can show areas that are prone to flooding. But now they are changing the maps because after the maps, they need to readjust them after the last events. Like Sandy, for example, completely changed our understanding of flooding on the East Coast because we didn't know such an event could be possible. But yeah, through all you can do, I have instruments, if I can come to your house and tell you. But the FEMA maps are a very good starting point.
Actually, the USGS topographic maps show the elevation of every place in meters above high tide. The FEMA maps only show the flooding zones, which is of course derived from elevation and rainfall. So the USGS maps you can get in a bookstore probably.
Yeah. And also Google Earth. You can just click on Google Earth. It's not very precise. Probably the error is like 1-2 meters or more, but you know where you are.
After living in California, all we heard, having grown up in Boston, was like, how can you live out there? Aren't you worried about the earthquakes? Now I come back here, and it's, aren't you worried about the flooding? And I remember seeing an article last year about proposing to close Back Bay streets and flooding it and making downtown Boston look like Venice. And they were proposing that, I think it was like a year and a half ago. So my big thoughts were about that.
They had this call for projects called Living with Water. Actually, it was a very good idea from from the city of Boston. I think the mayor was, and they had all these projects coming in, try to cope with sea level rise and possible flooding. And some of them, so they were very much in a theoretical stage, so nothing will be done. But it was just a way to start to rethink the city of Boston with events like Sandy. And so for the large scale one, the one that won actually was the company that was part also the Venice gates. So in Venice they're building gates, because Venice is the most dramatic example with New Orleans of flooding. London was very bad as well. And then London built gates, St. Petersburg built gates to stop, and now Venice is building gates. We have the gate in Charles River, but that will not prevent the waterfront.
Should we build jetties or dams further around Boston Harbor to prevent mass floods of water, or
so that,
Venice, Boston becoming Venice?
Yeah, we are a little bit higher than Venice, which is a positive, and hurricanes are not as extreme as Louisiana because the ocean is too cold here. But eventually, so the project, the call for projects was you need to hypothesize an event like Sandy happening in Boston at high tide. So when Sandy came in Boston, we were lucky because it was low tide, and the tide is very big in Boston. It's like 3.6 meters. So the surge was a low tide. It didn't add much more. But if it was high tide, we would have like water coming in. So if you think more, I would be more extreme. I'm proposing something radically different. I'm proposing that we should be mobile, even a certain level. And there are cases. So one place where I work in Virginia, they used to have a village on an island, and then the island started to move, and the village went underwater. They moved the entire village, and they moved inland. So this is very difficult for humans to relocate. But there are a lot of, like UK now, they have a lot of realignment projects in which they shift the boundary completely.
So in materials research, there's this concept now of biomimetics, where they're learning from natural materials and they're trying to design new materials, learning from nature. And so I'm wondering, are you proposing, I mean, the mobilities is you would move away and then the shoreline moves, right? But the salt marshes are these marshes that somehow, you said they can grow. Can you imagine human development where the architecture and the infrastructure is more like salt marshes that it adapts? And is that the kind of stuff that you're thinking of?
I think we should rethink completely the way we build the shoreline. So the marshes now are a very hot topic because a lot of people are advocating to increase the marsh land. It's called living shorelines because they are so effective at stopping erosion. And they also somehow mitigate a surge in water level. So they're thinking to rebuild the marshes in Louisiana, for example, or add more marshes in New York, near New York City, to prevent the preventive effect of new hurricanes. I think a lot of science is still missing to understand how it works. I just say we need to rethink completely how we approach the shoreline. For example, for me, even ownership. So I speak about like my mom has a condo, and we are like 1 meter above high tide in Venice. So we need to think ownership. That house might not be there eventually. So what's the point to own something that is ephemeral? And there are all these people in Florida. They have all these. They build in front of the beach, and then the beach is gone. And they ask the state to put sand. They spend like $1 million every year to put sand. I think we need to rethink completely how we approach this. And I don't have answers. I really like the crab. Like they know what to do. They know what to do to be, things come, water comes in and comes out. Actually, Venetians somehow are crabs because a lot of them don't want gates. They don't want the gates to stop they're okay with this amount of water. So a big chunk of the population is okay to go underwater so much once every 2 years. And they say, you know what, I'm going to buy boots and whatever. Then it comes to the very high one, like that. And then they get very upset. But, so, allow some sort of flooding as could be a solution, like they do. Yeah, it's a very complex topic. Like, for example, raising houses makes sense to me. A lot of places now you build on stilts, in Virginia, in Florida, in Louisiana. That allows the water to come in and out. Build also, you can totally build buildings that can resist hurricanes, if you want to. It's going to be expensive, but.
When we manage environments like has been done in Boston to stop flooding, does that actually impact the adjacent areas? Does it make them more prone to flooding? The areas that haven't been managed?
Not too much, because when the flooding is coming, it's the entire ocean that's going to go up. And it's going to up all this. The difference in elevation are in a very large scale. It's the size of the hurricane. So the entire area goes up, not only here, but also Gloucester. So you can stop with the gate, but it don't affect nearby areas. But we need to, so this is the goal. I think as a first step, we need to be more aware of what's going on in this landscape. We need to be more aware where we built and why we built here, and our relationship with the water that we completely lost. And the more technological, so there were people in New Orleans, they didn't know they were underwater. They didn't know they were below mean sea level. New Orleans could have been much less problematic. So Venice is not as bad as New Orleans. You know why? Because it's above mean sea level. So the water comes, the water goes away. In New Orleans, the water stayed there because it was below mean sea level. They had to pump the water out. And people didn't know that. That would be scary to me. I think we should just to be aware of what's happening. It's a major advantage, because then we know how to act.
So I've seen some maps showing the effect of climate change and the rise of levels and hemorrhages. Do you take that into account? How do you do that into account?
Develop this talk in a particular way. I never talk about climate change here. And I never talk about sea level rise, if you noticed. Because I think we need to, so of course climate change, global warming, and sea level rise are gonna increase the speed of all of these. But my message is much more radical than what you think. I'm saying that doesn't matter climate change. We are in a place that is very dynamic with and without climate change. We are in a place in which we had hurricanes even before global warming. We had the tsunamis even before global warming. The sea level changed in the past anyway. Okay, I'm saying that climate change is going to be much worse, because now the water can be much higher, as you said. But it's not that I fix climate change and I solve this problem. This one is the nature of the shoreline. I'm saying that we are building in the most energetic place on Earth, in the most dynamic place of Earth, in which I see change at a human time scale of the things. Global warming and sea level rise are going to increase dramatically all this process. This is why we see much more. But even if I stop completely global warming, I stop completely CO2 emission, I still have this problem. So is the way we build at the shoreline is not compatible with the nature of the shoreline for me in many places.
Martha's Vineyard, people keep telling me, is going to be totally underwater in 20 or 30 years maybe, maybe longer. And I just wonder, is that because of climate change, or is that because of being on a shoreline?
There are all these projections of sea level rising, due to global warming. So if there is a warming of the Earth, you have an increase in sea level. this is historic. We saw it in geological record that times in which it was colder, the water level was lower. The water level here was 100 meters, some places was 100 meters less than now. 20,000 years ago, not too long ago. So there are all these projections by which if I warm the planet, sea level will rise more. And then if you are in a low location, then you have more flooding. So we have to compound that. So there are all these maps in which they have a lot of very different approaches to look at sea level rise. It's a very hot topic, also very difficult to understand how much it is, but they can give forecast. And based on how much higher is the sea level, they can tell you if you are above or below. The thing they don't do, they don't show that the sea level is not going to only rise, but you're going to have a complete modification of the shoreline. Because when sea level is rising, you get all this energy, waves, hurricanes. So what they are unable to do is to look at the complete reorganization of the shoreline during this sea level rise. So we need much more research for that.
Okay, I think that about does it. Thank you, Professor Fagherazzi. Let's have a hand for.
Soil particles are electrically charged, and they have a slight negative charge on them, so they attract positively charged ions like calcium, right? And if we take hydrogen ions, which are in acid, and flood the soil with hydrogen ions, it replaces the calcium. Calcium gets
Just
kicked
like
off
that.
and goes into stream, and then the calcium's gone. And the calcium is only going to be replaced by chemical weathering of that till in the bedrock from below, and that takes a
doesn't
long
happen
time.
overnight,
Yeah,
does
that takes
it?
a long time.
Right.
Right. So
Right.
once you lose that fertility, it's really hard to get it back.